Oh, interesting. A geometric figure that doesn't have any points or sides or anything labeled on it. I'm tempted to start thinking, loading geometric formulas into my brain, but I don't even see any labels. I don't even, glancing down at the question, there's some numbers in there. Well, they're in an algebraic format with a variable a there rather than just some numbers, so that does actually look like we're going to be dealing with area of a circle formula, so I go ahead and start loading that into my brain, although it just strikes me as odd that there's nothing labeled on this this figure, but certainly can describe what's going on in words, so let's read those words. In the figure above, the square has two sides. The square, this is a square. I'll just trace it over my figure. Trace over it with my finger and tell myself that's a square. It looks like a square, but just because it looks like one on the picture doesn't mean it actually is. Figures aren't, just what it looks like isn't necessarily exactly drawn to scale, and so it's important that they told us, yeah, that's a square. The thing that looks like a square is, and it has two sides which are tangent to the circle. Again, that certainly looks like those, that would be the top one and the bottom one. It looks like they're tangent to the circle. If the area of the circle is 4a squared, and I'm just tempted already, I'm just thinking in my brain, 4a squared pi equals 2, pi r squared. I gotta make sure I'm thinking of the area and not the circumference formula for a circle. Pi r squared, where r is the radius of the circle, and there's a red flag going on as far as, in my mind, as far as it looks like the center of the circle is, well, it kind of looks like it's matching up with the midpoint of the side of this square, although not exactly. I think it does, but I want to be precise about that and think it through to be sure. But what is the area of the square? Well, it's, my intuition is telling me that, I mean, just, based on the look of it and the fact that this is a square and these two sides are, what did they say, tangent to the circle, that it seems intuitively clear that this side of the square is going through the center of the circle, and that we've got radius r here. The side of the square is 2d. I want to jump ahead, and this is r, 2d, 2r. I want to jump ahead, and I think I can get an answer that I feel good about, but I haven't, as clear as it seems to me that writing things in this way is fair and reasonable to do, I have some doubt about that, and just don't feel entirely good about it. I want to come up with a clear geometric proof, but I think that, we're good enough to go, everything seems reasonable assumptions, we're good enough to go, we can get an answer. I really want to be able to choose what our answer is. All this pi's cancel out here, and it's got a square on both sides. It's just begging us to take the square root. Now I assume that a is probably positive, although technically if we take the square root of both sides we should say plus or minus, because a could be negative. Is a positive or negative? We don't really know. R, the radius of a circle, the length, we should say, r has a geometric meaning. It's the length of the radius of the circle, or half the side of the square. So it has a geometric meaning, so it's natural for r to be positive. A doesn't have any geometric meaning, at least that I know of yet. A is just part of an algebraic expression, so it could be positive or negative. We'll see if it matters. If 2a equals r, then 2r equals 4a, 4a, which is the side, one side of the square. And so the area of the square is 4a squared, 16a squared. That looks like our answer, and it turns out the sign of the a doesn't matter, since we ended up squaring it. This has got an a squared in it, and this has got an a squared in it, so since a is always squared in both cases, it really doesn't matter whether it had been positive or negative to begin with, so that gets that off of our case. If it had been something like this, there would be some room for concern as far as should we be worried about a case where a is positive or negative, but since we're dealing with a always being squared, the sign of a doesn't really matter. I do have some sense of caution. Did I double something when I should have negatived? I mean, double something that I should have taken half. I sometimes do things backwards. If this is r, if the side, make sure I modeled this right. The area of the circle, 4a squared pi, is pi r squared, where r is the radius. And 2a equals r. 2a, yes. 2a squared times pi. Area of the circle is going to be 4a squared pi. Then the side of the square is 4a, which squares to 16a squared. So I feel good about that as my answer. Although there's still the point of concern, did I really prove, am I really sure that effectively the midpoint of this side of the square is the center of the circle? Let's see if I can. I would feel good enough. I mean, the intuition here is strong enough. I would move on, but I would want to definitely come back either at the end of the test or post-processing later and convince myself with more mathematical rigor not a very good drawer of pictures, but I mean, the picture doesn't have to be precise to get the mathematical principles right. These two guys, this is a square. I mean, these two are naturally perpendicular to each other. Parallel to each other. This line and this line are perpendicular to each other. If I've got a circle, the tangent line, and I draw a perpendicular to that tangent line, that's going to go through the center of the circle. If I draw another tangent line, drop a perpendicular, that's going to go through the center of the circle. Now, if these two lines, now if this is a straight, if from this point to this point is itself a straight line, then these two guys, it's intuitively clear to me that these two guys will be parallel to each other. Although how am I going to prove that? If I have to write a rigorous geometric proof, that seems clear enough, but it's just not I want to be really technical about making sure can I square, see if I move, wait a second, if I move my circle in a little bit, wait a second here. I've got a square. Now, if I take this point, okay, I can construct it. I've got two thoughts going through my mind. One, which is, I think my answer is fine, but I may have been making a false assumption all along. I don't think it's going to change the answer. Two thoughts. One is, let's say that I want to construct a circle that has, well, that has the midpoint of this side of the square as its center, and has these two corners of the square on the perimeter of the circle. I can certainly do that because this length is equal to this length. Tangent is going to be a right angle, which is what a square needs to have as its interior angle, and the tangent down here is going to have a right angle as the square needs to have, and I can go 2r over this way to construct this point, and I can go 2r up, construct this point, which is the same as 2r over here. I mean, I guess what I'm saying is given one side of the square and the two tangent lines, I can construct the circle inside of there, and then I can construct the rest of the square. And so it certainly is possible to have this configuration, but then as I started to draw up there, it's not so pretty. But if I take this configuration and I squeeze not squeeze, but pull, because nothing is changing its shape. The square and the circle are remaining a circle. But if I pull this circle in a little bit, which as a matter of fact, that's kind of the way that it looks like it was drawn in the original thing. The way it was drawn, it looked like the center of the circle was a bit off, a bit inside of the side of the square, which wasn't. I still assumed that the midpoint of the side of the square and the center of the circle lined up, that they were the same point, because you just don't. I mean, figures aren't. You can't take the figure to be literally drawn perfectly. So you got to, base your conclusions based on geometric facts that are stated in the question, and not just how the picture looks. But that did get me to thinking, what if it is pulled in a little bit? I could have a configuration like this where the center of the circle is actually here, and if you were to draw this and this, it's still perpendicular. The sides of the square are still tangent to the circle, which is what I was being required. Figure above the square has two sides which are tangent to the circle. As a matter of fact, I mean, based on the way that the circle could be right smack dab in the middle, even though it's really hard for me to draw a circle right smack dab in the middle of a square. It could be, in which case, I mean, this says it has two sides, but I mean, it could have all four sides. I mean, the circle could be right smack dab in the middle of the square. And this would still be tangent here, and I'd have R here, I'd have R here. I'd have a side would be 2R, I'd have pi r squared equals 4a squared pi. and I'd have r equals 2a, and I'd have the side of the square is 4a, and the area of the square would be 16a squared, even if the circle was right smack dab in the center of the square. So it doesn't actually matter. This circle can kind of move back and forth laterally this way, and I was thinking, so I actually did make a false assumption. My intuition was wrong, which is precisely why we have to be rigorous in mathematical conclusions. My initial intuition was that the center of the circle was actually falling right on the side of the square, and that doesn't have to be true. That's why I was having a hard time proving. I was trying to think how I was going to prove it, and it didn't seem obvious. And actually, you can't prove it because it's not true. It doesn't have to be. It could be, but it doesn't have to be. But regardless, that actually ended up not mattering. The diameter of the circle was still the same either way, and the side of the square was still the same either way. And so this is the area, but it's so my mathematical intuition helped me to get to an answer quickly. I mean, all of this, if I wasn't writing it out for you in longhand, I would have. I mean, the intuitions, I kind of jumped over the temptation to try to be rigorous in my geometric proof of what I thought was true, and I just jumped into finding an answer based on my intuition, and it paid off. But I'm also glad I went back and thought more about it and convinced myself, you know what, oh, actually, you're making too many assumptions. But even if you drop those assumptions that you can't prove because they're not necessarily true, even if you drop those assumptions, you still get the same answer. But it's yet another reminder that something that, you know, I thought that having a square and a circle in which two sides of the square were tangent to the circle, I thought that meant, oh, well, clearly the center of the circle is the midpoint of the side of the square. Well, no, it doesn't have to be. You can move that circle in a little bit, put the center here, move the circle in a little bit, and you've still got two tangent sides of the square. Two sides of the square are tangent to the circle, and the center of the circle does not correspond to the midpoint of the side of the square. So again, you know, pictures can be deceiving, intuition can be deceiving. Mathematical precision is important, but fortunately, it didn't affect our answer this time, and so I feel good that we got the right answer.